Start recording. I'm going to try and stimulate these connections that you built about a week, 2 weeks ago. So let's start first with our definition of learning. This is the chapter we're on, and we are trying to figure out how exactly this occurs within the brain, and hopefully how you can use this information for your own personal benefit. So what is our definition here? And try to remember this without looking at your notes. Can you activate the connection in your brain that is responsible for the definition of learning? Yeah, go ahead.
I was gonna say it was about it had to be permanent, right? So you have to remember it permanently.
Good. First off, that's a great technique. If you can't remember the whole definition, just try to remember a portion of it that you do. So there's a permanency here. Something is hopefully at least relatively permanently doing something. Okay, what is happening? So what's relatively permanent?
Well, I guess you can't really say what you learned is learning. It's what you practiced, maybe.
Yes. Okay, so there's going to be a relatively permanent change in something as a consequence of practice and experience. So yes, it's going to become relatively more permanent the more you do it over and over and over again. Yes. So what is that change? I mean, there's an operative word here. It's a relatively permanent change in what?
Behavior.
It is behavior. Remember that in this class, we're defining behavior as anything you do. It's what you can observe. So that is really the focus here, is if you've learned something, then presumably there's going to be a change in how you actually act. It's going to be a change in what you actually do. If I can't see what you're doing, then I can't be convinced that you've learned anything. It might be in there, but now you can't bring it into kind of conscious awareness. So if you can not only sort of remember this definition, but actually recite it, that is, you can actually prove that you know it, then that would qualify as the definition of any relatively permanent change in your behavior, in your ability to recall that definition. That's brought about by experience or practice. Now, if you didn't go home and you didn't recite this to yourself, you didn't think about it, or you haven't gone over your notes, then maybe you didn't experience it, maybe you didn't practice it very much. Therefore, the connection in your brain that is responsible for this definition of learning may be very, very weak. It may not exist at all for some people. So to remember this definition, you're going to have to recite it over and over again to create that relatively permanent change. Okay, then we went over this, which is a subdivision. It's a type of learning. So what is associative learning?
Oh.
Yeah, go ahead.
I want to say that it's is it okay if I look back at my notes for this one? I was gonna
You
guess, but I was
may.
gonna.
You may.
Okay.
It's always good
Um,
practice to try and not to, but you know what? If you can't remember it, you can't remember.
I was gonna say learning that two or more events are related.
Okay, good. Learning that two or more events are related. So it's still a type of learning in that there's some change happening, and presumably it's a physical change within your brain that's caused by experience or practice. And what that experience is you are creating a connection between two things. You have some experience and you learned, A is connected to B. That's pretty much, I mean, that's the basis of most learning. When you learn something new, you're learning that two things are connected. When you learn the definition of learning, you are connecting the word learning with all these different pieces of the definition I've given here. It's a relatively permanent change. in behavior due to experience or practice. You're creating connections between the word learning and these words. So that is associative learning. It is a learning that two events, two items, two things are connected somehow. So then last week, before our holiday, we learned about classical conditioning. So this is in the learning chapter. Why? How is this a type of learning? What is classical conditioning?
It's where after a set of events happen, a person or an animal makes a connection that a specific thing is going to happen.
Very good. I like that. So there's a connection being made. They're learning something, and specifically that something is about to happen. I think that's a really key part of this definition. That's what makes it stand apart from other types of learning. If you think of one word when you hear classical conditioning, what I would suggest you think of is the word predict. You're learning that one thing which previously meant nothing to you predicts that something that you are interested in is about to happen. So what's our example for this? Give me some examples of classical conditioning that we've gone over, that we learned about, that you were tested on, etc. Yeah, go ahead, William.
The one with the dog and the food, which was where you had the neutral stimulus, the unconditional stimulus, and then the dog. And
What
then
was that? What was that last step called? So when you look at the dog and the dog is salivating, that is considered the
that the conditioned response, right?
good.
Or
Yes.
unconditioned response originally.
Yes, it's the unconditioned response. A dog will naturally salivate to the sight of food. And so it is unconditioned in that it didn't need to learn that. It's just a response that it already has. Okay, good. So how do those three parts fit together? The bell, or the metronome in the case of the original experiment with Pavlov. The bell, let's just stick with bells. The bell, the food, the dog. How does that all work?
Whenever the dog would hear the bell, it would start to salivate because it knew food was coming. Well, it was trained that first in the original. And then the condition stimulant became the bell, and then the salivation from the dog because it just thought food was coming.
Good, very good. So someone else, describe to me that process. How would you teach a dog to salivate to a bell? So that is correct. All that is the sequence of events is correct, but what does that actually look like? How do you train a dog to salivate to a bell?
Ring the bell and then give several trials of bringing the dog food 30 seconds after the bell rings. Do this several times, and eventually the dog should make the connection that the bell means food is coming.
Perfect, good. So a few features there. That neutral stimulus, the bell, that originally means nothing to the dog. You ring it, the dog goes, I don't care about that, it's just a bell. What you need to do is present that first. That always comes first, because that's the thing that the dog is going to use to predict that something will happen in the future. Ah, bell means nothing now, but if I ring the bell, then I present food. The food causes the dog to salivate. Eventually the dog will realize, ah, that bell predicts that food is coming. And so then it will start to salivate to the bell after repeated trials, because it starts to realize, ah, that thing means food's coming. So I'm already going to start the saliva. My salivary glands are already going to start producing saliva to prepare for digesting that food. Good. Okay. Here's a definition of classical conditioning that I think is clearer than, I don't actually think I gave you a formal definition of classical conditioning, but this is really what's happening. It's a learning process in which you associate a neutral stimulus, such as a bell, something that means nothing to you, with a naturally occurring reflex, which would be the unconditioned, it should be UCS, USC. I've been working here too much. UCS, the unconditioned stimulus. So it's associating that bell with the thing that causes a naturally occurring reflex, that food, that causes the unconditioned response of salivating. Again, think learning that one stimulus, one thing predicts that another is going to occur. That's classical conditioning. So this is our example again for those of you who prefer kind of visuals to figure this out. We have the unconditioned stimulus. The food naturally causes salivation. So these are both unconditioned. We then have a neutral stimulus that when you ring a bell around a dog, originally it doesn't do anything. It doesn't care about that bell because the bell means nothing. If you present the bell first, then the food, and the food causes the unconditioned response, and you do this enough times, eventually the bell cues the dog into saying, ah, the food is coming, I should start salivating. All right. So hopefully all of this was review. My hope with all of this is that you already had these connections in your brain. You've already learned this stuff. And now that I've stimulated it, it's stronger. It's going to be in your brain for longer, so that one day when you have to think about this again, which you might, it'll be there and it'll be a little bit more well established. Beyond that, though, what I want to do is I want to take this concept and I want to build upon it. I want to show how classical conditioning occurs in our everyday life. It does. It happens all the time, and we're usually not aware of it. And when you're not aware of these things happening, they can sometimes cause headaches, not perhaps literally, but figuratively too, where these things are happening to you. You don't realize they're happening to you. And then maybe you get into certain habits, you start to expect certain things, and you're like, why did I expect that? Or why did I do that in this given situation? So let me give a concrete example of that. One of the things we know about classical conditioning is that it's a basic feature of the nervous system. It's not something that you tend to see, say, in more complex animals, such as humans, versus, relative. I mean, we can talk about complexity in a more complicated way than this, but say organisms with larger, more complex brains versus organisms with relatively less complex brains, like dogs and rats and worms. You see classical conditioning cutting across all species. If they have a nervous system, they can be classically conditioned. So this is a really basic process. You can train a dog to hear a bell, pair it with food, and therefore cause salivation. They've done this with rats, and they've done it with things like alcohol. It turns out rats originally don't really like alcohol too much. Rats are actually very, very picky eaters. You wouldn't expect that because you associate rats with trash and rotten food and all that. But generally what rats will do is when they find food, they'll actually kind of assess it very carefully. They'll consider, where did this food come from? How did I find it? They'll sniff it to make sure that it's not, say, too rotten that it would cause them, that would make them sick. So alcohol is one of those things where if you put it in front of a rat, the rat will sniff it and it'll go, this doesn't smell very good. If I take a little lick of this, it doesn't taste very good either. However, what they've done is they've actually trained rats first to enjoy alcohol by usually mixing it with a lot of sugar. So they put a lot of sugar in there, which is something some of you may relate to. Some alcohols are easier to drink if you put sugar in them. They put the sugar in there so that the rat actually drinks the alcohol. Oh, Austin, yeah, I see you have your mic open.
I'm sorry, but there's just no way you can make beer taste or smell any better than it does.
I guess my argument is I agree with you. I feel you there. However, my argument is if someone already hates it, putting sugar in there might make it easier. I think that's the logic behind like a, you know, Mike's Hard Cider or something like that, where you wouldn't drink alcohol, but because it pretty much tastes like lemonade, now you're more likely to drink it. All kinds of clever ways to get people to do drugs in the marketing world. Yeah.
Same thing with coffee, right?
Yeah, right. No, exactly. Coffee usually doesn't taste very good unless you have an acquired taste for it. You've drank it a lot. You put some milk in there to balance out the acidity, and then you throw in some sugar to make it taste sweet. All of a sudden, oh, okay, I can drink that now.
I like to drink it black, but I know a lot of people love to put like tons of stuff in it just to take it.
Yeah, no, I'm the same. I didn't like coffee. I still don't like coffee that much because I find that it's too caffeinated. It kind of makes me too jittery. I've gone to tea, but when I do drink coffee, even when I drink tea, I don't put anything in it just because, partly because I don't want to be intaking all that sugar. I don't want to be intaking that, some people put creamer in there, and creamer has a lot of fat in it. So yeah, I just take it as is, but I've acquired that taste over time.
It's just nasty when somebody puts like milk, it waters it down, it feels like, but anyway.
Right. Yeah, so they train these rats to drink alcohol, all right? They just they put sugar in there, the rats start to drink it. Then the rats start to realize, oh, you know what? I kind of like alcohol because it makes me feel a little loopy. It kind of depresses the nervous system, it kind of slows things down. They get the same reaction from alcohol that humans do. So then what you can do is you can string, say, something like a light behind that alcohol, where a light flashes in the cage where the rat is being stored or being housed, and then it knows that alcohol is coming. So what it'll do is what usually happens in these experiments is the rat will approach the spot where the alcohol would be normally administered. So the light flashes, the rat goes, oh, that means alcohol's coming. So it'll go to the device that administers the alcohol, and then it'll wait there. So that's approach behavior. That's what you see under a conditioned response. It approaches the area where the alcohol is going to be dispensed.
Has this actually been like a study?
These are some of the older studies. So a lot of the older studies in psychology were done in like the 60s, 70s, into the 80s on rats, really basic stuff on rats. And yes, they've actually done this. If you'd like the original source, I could look it up for you and actually get that for you. That would be.
I just had one question. Did the rats seem to approach it more energetically than they would anything else, or?
Yes, usually energetically. And it turns out if you use harder drugs, the rats respond even more energetically. They've actually done experiments where they directly tap heroin into a rat's, oh my God, the name is escaping me. It's the septum of the brain, which is part of the pleasure center. So where you're going to form a physical dependency on a drug like something like heroin, they just dumped it straight into that spot. And you find out that after a while, what'll happen is if you train a rat to expect and want heroin, which doesn't take too much effort, they will actually, if you give them the ability to self-administer that heroin, they will keep hitting that lever, keep trying to get the heroin until they kill themselves. So they'll easily OD on heroin if given the opportunity. They do so very energetically. Yeah. You were going to follow up on that?
It's crazy to think that you can create an addict from a rat.
Right. This is one of the cool things that we're going to learn is when it comes to physical dependency, again, this is not something that is unique to humans. It's if you have a nervous system, that nervous system can be altered. It can be trained to develop a dependency. So you can really get anything with a nervous system addicted to a wide range of things. Drugs just happen to be the easiest because they're designed to very heavily influence and shape the nervous system and to affect it. So this same logic is the logic that applies to how marketing agencies attempt to train people to want certain products. If you've started to associate, if you just even have a baseline, a very simple association between alcohol and the effects that it causes. So that is, it slows you down, it makes you feel more uninhibited, which is what alcohol does. It suppresses what's called the prefrontal cortex of the brain, which is the part of you that is responsible for inhibiting your behavior. So when you drink alcohol, you will feel more uninhibited. And that's usually what people really like about it. So if you have that baseline association, alcohol doesn't taste that great. It's kind of got that, it's got a bitter taste, especially if it has a lot of hops in it with beer. You say, I don't really like that for the taste, but I want it for the experience. As soon as people understand that, what they might start to do is start to associate certain brands of beer with certain experiences. So for example, some of you may not be old enough to kind of, let's hope that you haven't had this experience, but you go out somewhere and you just have, a kind of a rip-roaring night, and you were drinking a very particular type of alcohol that night. And let's say that, you got up on the dance floor, you had a lot of fun, you danced with people that you really wanted to dance with, the rest of the night was just fantastic. What you might do is you might actually associate all of the things that happened to you, not with the people you were around, not with kind of your mood that night, not necessarily with just the alcohol itself, but you might say, oh, that was the night that I drank Jameson. That was the night that I, got wasted on Guinness, right? So what you start to do is, rather than associating the alcohol with the experience, you might start to chain together through classical conditioning, associating a brand with a certain experience. And that's how they get you.
Is it the same way for just types of alcohol? Because I figured out really quick that unless I'm home, I don't need to be drinking whiskey.
Right. So, I mean, there is some complexity to alcohol, especially for those who I think are very experienced with it, where certain types of alcohol have a different taste. And so one of the things you could do, for example, something like a dark alcohol tends to be sweeter versus something with, kind of like a pale ale or something tends to have a lot of hops in it. It's more bitter. You could start to associate, say, the bitterness with the experience that it causes, or the sweetness of a darker beer with the experience that it creates. That's also classical conditioning. It's really the alcohol. It's the effect of the alcohol on your brain that's giving you that experience. But you might start to associate that taste that comes beforehand. Oh, this was very sweet, or oh, this was very bitter in just the right way that I know that this experience is about to come. If I taste a hoppy, very bitter type of alcohol, I know that I'm going to have this kind of experience, for example. So yeah, you can associate different types of alcohol with different experiences, and I think people do that. Now, whether those alcohols actually cause a different experience, I'm not convinced of that. I think that there are some types of alcohol that are higher content versus lower content, and so you're going to become drunker more quickly. But I'm not. I think people just kind of. I have no evidence to back this up, but I suspect that people start to associate certain brands with just experiences that they've had, and then they start to assume, oh, if I drink whiskey in this context, I'm going to get the experience that I'm looking for. When in reality, you could drink a different type of alcohol and get that same experience. I think it's mostly because of the previous experiences that you've had. But again, I don't have evidence of that. So I could be convinced otherwise. So this is classical conditioning in humans. It happens quite a bit. All right. Now, as part of the review, I want to, again, delve into biologically, how is this learning occurring? So when you start to associate, say, you start to associate a bell with food, or you start to associate branding with a certain type of certain type of experience. Biologically, what's happening in the brain? How is that learning happening? What was the term that we used to describe how those connections are formed? Good, William.
It's been a while, but I'm gonna guess that we're referring to the neurons in our nervous system.
Yep. And what aspect? What part of that neuron and what's happening? What's it called?
Axon terminal.
Good. So we're looking at the axon terminal, which is the very end of the of the neuron. And what's happening there?
Information is traveling to the brain.
Okay. Can you guys hear me now? I think we got disconnected
Yeah,
for just a second there. Okay. I think we lost William too. Okay, we're at the end of the axon, and so yes, information is being, let's see if we can wait for him to come back, because I don't want him to miss this. Who wants to jump on top of that? So does anyone else kind of want to pick up where he left off? So there is information being communicated, but I'm specifically asking, how do we create? So when you learn something, a connection is being formed that did not exist before. What is that physiological, that biological process that creates that connection? Does anyone remember that? It was a long, complicated term. I've mentioned it probably 2 or 3 times before. I told you to put a star next to it in your notes.
Can you repeat that one more time? My browser crashed again. Never fails.
Yeah, I had a disconnection issue too. What's that process by which one neuron connects to another, and then that connection becomes stronger?
Isn't it when the axon sends signals to the nerve synapse? And
yes.
then it goes across to, or by the other neurotransmitters.
Yes. So there is an electrical charge. It's being sent through that neuron. It gets to the axon terminal. And once it's there, that charge is going to cause the axon terminal to release neurotransmitters. So that electrical charge causes a release of chemicals. That release of chemicals. Yep.
Oh, sorry. I was gonna say that's the definition of it would be long-term potentiation.
Okay. Good. So when those chemicals are released, they bind to the next cell, and they cause the next cell to, if it's a neuron, say fire, to create its own electrical charge. Okay, long-term potentiation, that is the term we're looking for here. Long-term potentiation is the process by which a connection between one neuron and the next neuron becomes stronger through repeated stimulation. So it's becoming stronger through repeated stimulation. And that stimulation causes more neurotransmitters to be released and more of the receptors on the next cell to form and be able to accept those neurotransmitters. So the connection becomes stronger. All right, you've heard me explain this. I actually want to play a video that I think will supplement what my explanation. I think you guys are probably tired of hearing me explain this over and over again. So let me kind of give a different perspective on this. Let me see. I've been experimenting with some sound options, so give me a second to make sure that this works. All right, let me know if you guys can hear this. Are you able to hear any of that?
No.
I can't.
Okay, let me just do this the old way then. All right.
How do you learn? This is a tougher question than it seems. You might know that you learn by studying, for example, but what changes occur in your brain when you read a chapter for the first time or when you test yourself on your knowledge? You probably realize that your brain doesn't just grow new cells to store your memories, otherwise our heads would just get bigger and bigger. But what does happen is that the connections between neurons strengthen. This is called long-term potentiation, or LTP, and it's one example of synaptic plasticity, which is the ability of synapses to change their strength. So let's look at this process in more detail. Neurons communicate using electrochemical signals. That means a combination of electricity and chemicals. When neurons communicate, they actually don't connect to each other directly. There's a junction in between called the synapse. So we have a presynaptic neuron, which is the neuron leading up to the synapse. And we have a postsynaptic neuron, which is the neuron immediately following the synapse. When the presynaptic neuron is stimulated, it releases neurotransmitters, or special chemicals, which then bind to receptors on the postsynaptic neuron, opening channels to allow ions such as sodium and calcium to flow in. Now, all neurons have a surrounding membrane, and the interior has a different electrical charge than the exterior of the membrane. And this difference in charges is called the neuron's potential. The number of ions that flow into the postsynaptic neuron affect that difference. And this is actually how we measure the strength of the synapse, by how much the postsynaptic neuron's potential changes as a result of presynaptic stimulation. So what's really cool is that with repeated stimulation, the same level of presynaptic stimulation converts into greater postsynaptic potential. In other words, after the presynaptic neuron gets a lot of practice firing and sending signals to a specific postsynaptic neuron, it gets better at sending those signals, and it'll end up getting better at opening the channels to allow more ions in. When this happens, we say that the synapse strength is increasing. When this increased strength lasts for a long time, meaning anywhere from a few minutes to many months, it's called long-term potentiation. And this is thought to be the physiological mechanism by which learning occurs. As synapses are strengthened and as they retain that strength, we're able to more easily recall previous experiences.
Okay. So again, what we're talking about here is a physical change being caused by your experience. The more you stimulate a neuron, the stronger that connection, the stronger that change in your brain is going to become, and therefore it becomes more reliable. If you want to remember what the definition of learning was, the more you stimulate the connection that is responsible for your remembering that definition, the quicker you're going, the more quickly, the more reliably you're going to remember that definition. This is how studying works. When you study, as you go over material again and again and again, you are re-stimulating the connections that are responsible for that material. Yeah, go ahead, William.
I was just wondering, is there like a condition or just medical like maximum of how these neurons can like associate with each other? Like, is there a breaking point to where they just can't even become any stronger, or if they do, something happens?
So it's going to depend on which pathway we're talking about. So within the brain, some connections are going to have greater potential to be really, really strong. For example, in your cerebellum, which, what did that do again? It's in the back, it's in the lower back of the brain. What does the cerebellum do? What's that responsible for?
I believe at the back of the brain, isn't that that's the bottom of the brain too, right?
Yeah, back and in the bottom. It's that kind of mushy, kind of really textured part of the brain.
Motor movement.
Motor movement. So the cerebellum is responsible for your memory of how to ride a bike, how to walk, how to, crawl on all fours, things like that. Those neurons are very, very well prepared to build strong and complex connections. So those, the upper limit of how far you can take those connections, how well you can build them, it's pretty far up there. But there is a physical limit. I mean, there are only so many neurotransmitters that can be released and so many receptors that can be produced to receive more of those neurotransmitters that eventually, yeah, practicing more isn't probably going to do much for you. For example, at a certain point, if you get really good at making a jump shot, you're probably not going to get too much better after that. If you keep practicing, you might become even better than otherwise, but there's going to be a plateauing where eventually you can't train it anymore. Now, if you get to that point, is it going to like cause physical damage, or can you overdo it? No, it's not going to cause physical damage, but you might be wasting your time. Compare that to something that's a little harder, like you're trying to learn calculus. You do not have a very good natural predisposition to learn calculus. That's something that's hard because humans have not traditionally done that for most of their history. So the more you practice calculus, chances are the better you're going to actually be at doing calculus. Now, related to that, one of the things I'm going to be emphasizing in future lectures is that when we talk about a memory for something, for example, a memory of how to do a certain type of math, it's not usually just one connection. It's a connection between many, many, many different neurons. So even though there might be an upper maximum for a given connection between one neuron and another neuron, there may not be much of an upper limit, a maximum of how strong you can make connections if you consider just how many different connections you need to strengthen to remember something. So the complicated answer to your question is there's not really an upper limit, because most memories that you form are going to be a complex network of different connections, and all of those connections will need their own type of stimulation to keep them strong, if that makes sense.
Gotcha. That's weird to think about. Thank you.
I'm excited to get it to memory because that's really where all this just kind of sticks together and I think makes sense for a lot of people. Okay, so that's long-term potentiation. Again, this is a Khan Academy video, so if you would like to watch this again, of course you can see it in the recording of this class, but you can find this pretty easily just by Googling it. So if you want to review this, if you found that helpful, I recommend kind of adding that to your notes, things to study for this class. Again, I will be bringing up long-term potentiation again and again and again and again. It'll be important for you to remember. Okay, so what? So we know that long-term potentiation happens. How does this relate to associative learning and classical conditioning? If you delve very deeply into the science of long-term potentiation and how it occurs and its different features, there's a lot to learn. A lot more that I could possibly cover in this class as an introductory class. Excuse me. But there's one feature of long-term potentiation that I think, if you understand it, goes a long way to understanding how classical conditioning works and how classical conditioning creates a physical change in your brain. And that's associativity. Here's how associativity is defined as it relates to long-term potentiation. If one neural pathway, so the pathway between one neuron and the next one, is weakly activated at the same time that a neighboring pathway under the same cell is strongly activated, then both synaptic pathways will undergo long-term potentiation. All right, there's a lot there. Let's break this apart. I want to give an example right away. In the case of classical conditioning, what we're trying to do is we're trying to build a strong connection between something that is not, if we're training a dog to salivate to a bell, what we're trying to do is trying to build a strong connection where currently there is a weak connection or no connection at all. If you ring a bell, a dog does not naturally salivate. So what we're trying to do is associate the bell, the neuron that is responsible for interpreting the sounds of a bell, with the neuron that is responsible for creating salivation, for causing the salivary glands to produce saliva. So to do this, what we need to do, according to this principle of associativity, is if we want to make a weaker connection stronger, we need to pair it with a stronger connection. The food. The food already causes salivation. The neurons that are responsible for, say, the taste of food, the smell of food, the texture of food as it's entering the mouth, as you're sniffing it, as you're tasting it, that is already super highly connected to salivation. So if we want to associate the bell with the food and therefore with salivation, what we should do is present it right alongside the food. We want to present that weak connection next to the strong connection. So if one neural pathway is weakly activated, such as the bell, at the same time that a neighboring pathway under the same cell is strongly activated, then both of those connections will undergo long-term potentiation. Long-term potentiation, where you release more neurotransmitters, create more receptors, that will happen not only for the food connection to salivation, it'll happen for the connection between bell and salivation. So if you do this over and over and over again, you keep stimulating these things together, eventually a strong connection forms between bell and salivation. All right, reactions to this. Does this make sense? I mean, this is a very strictly physical mechanism by which you learn to associate, say, something that previously meant nothing to you with a particular response, associating a bell with salivation. Does this make sense? Does this help anyone understand how classical conditioning happens?
I think so, personally.
So let's think about alcohol and branding. Can you explain how you might have built up an association to enjoy a certain type of beer? Or, I don't know, I know some of you are, I think, are in high school, so I probably shouldn't be talking about alcohol as much, but we'll be talking about drugs plenty later, so, might as well get used to it now. But let's say that you've associated a certain brand of milk with a certain response. How did you build up, according to this principle of associativity, how did you build up an association between Walmart brand milk, which is just the brand of milk that you absolutely love, with, say, salivation or an expectation of, oh boy, I really want milk right now. How did you build that association with using this principle here?
For me, I guess it would be well, it's funny because I don't really drink milk, but in terms of that, I would probably say with my favorite cereal as well, um, which is shredded wheat. Uh, I would relate it to that cereal, which is also another brand.
Yeah, that would work too. So how would you have built up an association between a brand of shredded wheat and, say, how willing you are to buy it, say how excited you are to buy it? You see that brand and you're like, man, I want to eat that cereal.
Probably from the good memories of being at my grandma's house, actually, because that's where I think I ate shredded wheat for the first time, and I used not Walmart but Piggly Wiggly brand milk with shredded wheat. So that's actually weird to think about.
That's interesting. Yeah, it's funny how that makes me think of my grandmother's house many years ago. We used to go over there for Christmas, and what happens is, I think I started to there's a certain smell to your grandmother's house. I think for most people, I assume, you go in there and you smell it, and then you have this kind of this social gathering. You have this Christmas event, or you have this Thanksgiving event, and you have a good time. And eventually you start to associate the smell of grandma's house with these kind of pleasant childhood memories, right? Originally, the smell of grandma's house may have meant nothing to you. But what happens is, over time, you started to pair the smell of grandma's house with all the kind of social pleasantness, the warmth. Maybe, you watch TV at a particular movie that you love to watch, and so you started to associate the smell of grandma's house with something that was about to happen in the future. That is, you were going to watch a movie, you were going to eat dinner, you were going to have a good time with your family, those kinds of things. So where something previously meant nothing to you, now that smell means, these are the holidays. These are the times that I love. That's classical conditioning. Same with Piggly Wiggly milk, right? If you start, eating a certain brand of cereal, you're going to start to say, that is the brand of cereal that makes me that I enjoy the most, or that reminds me of, say, being at my grandmother's house. So now you might actually eat a certain type of cereal, not because it necessarily is an exceptional cereal, but because you used to eat it at your grandmother's place and you loved being at your grandmother's house. So now you eat that cereal because it reminds you of grandmother.
I never even thought about that. Now I have to settle for IGA brand milk. So
Yeah, I think that this is a powerful thing to understand, because what this does is, if you're aware of it, you could try to intentionally train yourself to like or associate a different type of milk or a different type of cereal with a new good experience, right? Maybe you create a tradition where you eat a certain type of cereal before going to see, I don't know, this is a really weird example, but before you go to see your significant other. You do that enough times, eventually you might say, I really like IGA milk because every time I drink it, I drank it before I saw the love of my life, and now I associate that milk with the experience of going to see my sweetie later on. My sweetie, who uses that anymore? But you know what I mean. You can intentionally build those connections.
yeah, that's where most people meet, is in the aisle of where the milk is located.
There you
So,
go. That fated encounter. Yes. All right. I want you to be familiar with this process. This is a really key part of this class, is understanding how long-term potentiation occurs that you are stimulating a neuron over and over again and building a connection. And then to learn something new, what you're doing is you're trying to stimulate collections of those neurons at the same time. In this case, the collection here is very simple. The collection is you are stimulating the sound of the bell, the neurons that are responsible for the bell, at the same time that or slightly before, the stimulation of the neuron that is responsible for responding to the food. When you stimulate those together, you actually build an association between the two. You start to learn that the bell means food's coming. All right. I would spend some time, think about this, review this in your own mind, try to apply your own examples to this. How have you undergone classical conditioning? For now, I'll give you a few examples. You should generate your own. I'll explain why next chapter, why it's the best practice to generate your own examples. But how about this? Let's talk about romantic relationships. Let's say that you get into a relationship. Maybe you've been in several relationships at this point, depending on who you are. This might have been your experience, maybe not. But again and again, every time you get into a relationship, after your partner has sex with you for the first time, they then ghost you. And everyone understands what ghosting is I assume. When you are interacting with someone, you're dating someone, and then very abruptly they just stop communicating with you and you never hear from them again. They ghost. All right, if you were to have this experience where every time you have sex with a new partner, they then ghost you, they leave you, you never hear from them again, what do you learn?
I would say that it's similar to another example we talked about, but I suppose that after having sex for the first time with somebody again, it would make you worried that they would ghost you, the next partner, I mean.
Yeah, exactly. What you're going to potentially start to do now, it's going to depend on who you are. If you're the kind of person who doesn't want to build a long-term relationship and your partner ghosts you, you might go, well, thank God, I didn't really want to be with them anyway. However, what I'm assuming here is maybe you're someone who's you really like this person. You decided to have sex with them and you're like, you know what? This is someone who I could see myself spending a lot of time with, who I'd want to maintain that connection with. So what happens is there's something kind of unpleasant happening where you build this connection, you're really excited about it, and then you lose it. Eventually, what you're probably going to learn is, well, geez, every time that I have sex with a partner, afterwards they lose interest in me. So what's happening is sex, which originally was what? In the model of classical conditioning, what here is the neutral stimulus? What is the unconditioned stimulus? What is the conditioned stimulus? What is the conditioned response? Can we identify these things? What is being learned here through classical conditioning?
Say that the neutral stimulation would be the would that be the that's actually weird because I'm trying to think either the neutral stimulant or the unconditional stimulant would be sex.
Okay, so
I think
what is, yeah, go ahead, sorry.
Be sex and then
Does everyone agree with that sex would be the neutral stimulus? Remember that really the definition of a neutral stimulus is something that previously maybe didn't mean anything, but after enough repetition, it becomes a conditioned stimulus. It does mean something. It means that something's about to happen. So would sex be
so
the
the unconditional will be the relationship, right?
Close, sort of. I'll give this just because it's so complicated. The unconditioned stimulus here would be being ghosted. Involuntarily, being ghosted will make you feel not great. If you are really looking forward to spending time with this person, if they then ghost you, you will feel bad about it. That's something you don't have to learn. So that's the unconditioned stimulus. So what is predicting that the unconditioned stimulus will come around? What is the neutral stimulus that you use then to predict that the unconditioned stimulus is going to happen, that you're going to be ghosted?
Sex for the first time with that partner.
Exactly. Yes. So previously, having sex with a partner, you didn't think too much about it. You're like, okay, this is, I enjoy this. Let's have sex. I feel connected to you. At first, it was neutral because it didn't predict anything. This happens to you enough times, what you're going to start to do is think, well, geez, every time I have sex with a partner, they then leave me. So now that sex becomes a conditioned stimulus to cause a conditioned response. What do you think might be your conditioned response if you've learned that having sex with a partner means they're going to go away? So if you really want to maintain a long-term relationship with someone, and you, in your experience, have learned that every time you have sex with someone for the first time, they leave you, what logically would be your response? How would you solve that problem? Well, yeah, go ahead.
Actually, I don't know.
I think what a lot of people learn is, well, if having sex with a partner means that they're probably going to ghost me, maybe I should delay how much time passes before I have sex with them. Delaying sex, you might associate sex with this negative outcome, your partner leaving you. So what you might inadvertently do is start to realize, you know what, I need to not have sex with them, or I need to delay having sex so that we maintain that long-term relationship as long as we can before they leave me. Or if it's to make it more complicated, probably spend more time making sure that that partner is not going to leave you before you have sex with them. This is also a type of classical conditioning. I think that within our romantic relationships, we get conditioned into a lot of different kinds of behaviors. I would think about that. Think about your style of connecting to other people, of forming romantic relationships. Is there something that you've learned through your experiences that you do? You could take this a different direction where you might learn very early on that even forming a romantic relationship means eventually it's going to fall apart. So what you might learn is, for example, you get into a relationship, you invest time, maybe you invest money, you invest something that is costly to you, you invest it into them, and then they leave, several weeks, several months later. And that happens again and again. What you could learn is investing time into a relationship is not worth it. People end up leaving. So your conditioned response might simply be, don't ever invest anything into a relationship. Keep your distance. Be a little bit detached. Don't build that form because you're just going to get backstabbed in the future. That is something that a lot of people learn, depending on your experiences.
I guess it's not against the rules of classical conditioning, but I noticed that the unconditional response is pretty different from the conditioned response in this sense, because normally the unconditioned response is something that can be changed, but this is more of like a learning experience than the same thing.
Yes. That is, I think with a lot of the examples, you probably noticed in a lot of the examples that I gave you for the test, for simplicity's sake, just to make it easy, a lot of the conditioned responses were the same as the unconditioned response. But when you start to really get your hands dirty, the response can be different. And the response was sometimes different in those practice problems we did. In this case, yes, the response is something different, right? What you're doing, really what the conditioned response is going to be is some response that you have given that you know that the conditioned stimulus predicts that something's going to occur. In this case, you realize that sex predicts that your partner is going to ghost you. So given that information, given that you know that, what you should do is perhaps change your behavior, right? Rather than just keep going with it and keep having sex and keep getting ghosted, what you're going to do is say you start to delay how much time goes by before you have sex with them. It's yes, it can be different, and that's the complexity of it that we won't really get into too much in this class, but that is possible, yes. All right. Something else I want to make you aware of, we've already talked about how advertising is heavily uses classical conditioning. Here's a very basic unconditioned stimulus and response that we have built into our nervous systems from very early on. We are basically born with this capacity to associate attractive people or hot bodies with sexual interest. So involuntarily, if you see someone or something that is sexually attractive to you, then you will experience some amount of interest. Say someone really attractive, moves to town, suddenly you start to think about them a lot, or you just can't stop, they walk by in the hallway and you're just involuntarily drawn to look at them and admire them. You go home and you obsess over them. You kind of get that, oh man, this is so interesting. I just love thinking about them. They're so attractive for whatever reason. We could talk about physically attractive. We could say, oh, they have an amazing personality. And so I just can't stop thinking about how just cool they are. This is a very basic, unconditioned response. You didn't have to learn it. And for most of human history, we've been very aware of this, and marketers, people who are attempting to sell things, have been very aware of this. So what we can do is we can use classical conditioning to sell different things. This is why in many music videos, you end up having backup dancers, or even the singer themselves tends to be attractive. We realize that more people will watch a music video more if it features someone who is attractive. Because what people do is they see the music, they hear the music, and maybe they already like the music, but then they hear that music next to a hot body, and they start to and what they're going to do is start to associate the music video with just that feeling that they get when they see someone attractive. So then when you hear the music video, you think of how attractive the singer is, and that makes you more interested in the video. We can talk about this in terms of social media. When you are scrolling on Facebook or Twitter or wherever you scroll, chances are, think about this next time you're doing this, as you are scrolling past, think about what you stop to look at. Some people are fairly well informed and they read news articles and they want to know more about the conflict in Myanmar. But a lot of the stuff that you stop and look at is probably stuff that featured someone who looked fairly attractive. I challenge you next time that you're on TikTok to look at how many people you are subscribed to that are attractive versus that you find attractive versus those who you find relatively unattractive. I almost guarantee you are subscribed to more people that you find attractive than those who you find unattractive. Probably because if you're watching TikTok, it's all about movement. It's all about, people dance too. a lot of it probably comes down to you just would rather watch someone dance who you find attractive than someone who's not attractive. That's the same principle. You learn to subscribe to someone's newsfeed by virtue of how they look. And again, this is how they sell food this way. They sell alcohol and different kinds of drugs this way. You present, say, a hamburger, and then you show a really hot model eating that hamburger. You're starting to associate the food with the arousal you might feel, or the pleasantness that you might feel by virtue of that connection.
When in all reality, ain't no mom gonna be eating a Whopper from Burger King.
Sorry, you kind of cut out. You got really quiet there. I don't think I quite heard.
When in reality, there ain't gonna be no model eating a Whopper from Burger King.
That's fair enough, right? Exactly, right. Yep. No, these things are very carefully. I mean, this is a very fine science at this point. Marketers are going to put elements together that maximize how likely it's going to get people to buy their product. And this is just one thing they do. And you're right. In reality, someone who is really physically fit, at least is probably not buying a Whopper, all the time, every week or whatnot. They probably have a much stricter diet. Yeah. All right. Do you guys want to throw out any other examples? Has this kind of inspired you to think about in your own life when you have been classically conditioned?
Maybe guitar. I play a lot of guitar, and trying to think back, it's funny because one of the first things that actually got me into playing guitar was the King of the Hill theme song. And
Okay.
I remember I liked the show a lot, and so I tried to learn that. And then I kept, of course, I can still play it, but that's not the thing that interests me about it anymore. It's much more complex, much more things that you would in reality apply to an actual concert or a show. Like if I'm playing on stage, nobody's going to want to hear that. Well, maybe, but they're going to want to hear something a bit more common, I guess.
Yeah, or relatable to a wide variety of people. Yeah, that's interesting. Yeah, go ahead, Austin.
I second that because I also play guitar. And when I first started, I just wanted to be your campfire guitar player, nothing fancy. And then once I got bored with the basics, I started trying to learn more difficult stuff. And I guess you could see that as classical conditioning, even though I do have a background in music in high school.
Yeah, I think that's a really good. I mean, I tried to learn, and I say try very lightly because I didn't give it much time. I tried to learn to play guitar back in the day, but I didn't put a lot of effort into it. And I think part of it was you see the kinds of people or the kinds of things that you can do with a guitar, right? Where if you are playing a guitar at a campfire, you entertain people. And so you might, as if you just already like to entertain people, you might start to associate the guitar with being able to entertain people. Therefore, you learn the guitar, not because you just wanted to learn the guitar, because you were just like, well, this is a random instrument I want to pick up. You might have actually had a very explicit thought of, you know what, people who have guitars, they tend to be liked within social groups. They tend to be found as relatively more attractive. We actually do know that. There are studies that have measured this, and they actually show that people with music ability and those who are capable of demonstrating that musical ability, they tend to be seen as more attractive by virtue of being able to create music. So you might be associating playing a guitar with, I don't know, being able to attract a romantic partner or being well loved.
I've experienced that firsthand.
Yeah, right. It's
Same here. Wink,
Yep.
wink.
Music is a gateway into a person's mind. If you can create music, it shows that you have a skill, and it also shows that you are fairly creative, especially if you can create your own music. And creativity is a highly, highly attractive feature, typically. I teach a class on sexuality. I probably mentioned this before. That's why all my examples come back to romantic relationships. Okay, so with the 2 minutes I have left, I want to leave you with a conclusion that I hope will help guide you through next week's material. So if learning is a relatively permanent change brought about by experience or practice, and this relatively permanent change is a physical change, it's something happening within your brain, this is the logic we can go through. Long-term potentiation is that physical change. That is the relatively permanent change that's occurring. When you change how the nervous system is structured, how one neuron connects to another, through more neurotransmitters and more receptors, which cause faster, more reliable postsynaptic responses, that is, it creates that behavior. What we're talking about is long-term potentiation potentiates certain thoughts and behaviors, which is just a fancy way of saying that it creates a tendency. If a connection within your brain is potentiated, that means that you will very easily and readily do it. If you in your mind have a connection for how to play the guitar, then when you go to play that guitar, it's going to happen very naturally. You're going to have a tendency to already be able to play that guitar in a certain way. If we think back to previous lectures, we have seen this tendency before. We called them heuristics, we called them cognitive biases. It's the same thing.
That's very interesting, because that's why I don't know what Austin plays, but I personally love acoustic guitar, and I love specifically complicated classical to Green Day to Tommy Emmanuel, stuff like that.
Yeah, I also play acoustic. I'm learning bass, but I stick with more country music and the music I grew up on, which is Christian contemporary and classic rock.
So in the interest of time, I'm sorry to cut you guys off, but just to make sure, because I'm sure some people have to go, I want you to digest this point, because this is how what we're learning now connects back to what we learned before. And I think this is going to help you understand operant conditioning as we move into it this week. So this week we're learning a different kind of learning, operant conditioning. It's learning that an action is associated with reward or punishment. As you are learning how operant conditioning occurs, think to yourself, how does operant conditioning potentiate a behavior? How does it make certain tendencies more likely, certain thoughts or behaviors more likely? How does it build a tendency to think or behave in a certain way? How are you building heuristics and cognitive biases? If you think about it this way, I think it's going to make learning operant conditioning much more enjoyable and much more interesting. All right. Thank you all for being here. I'll hang out for a couple of minutes if you have questions, but thank you all for being here, and I hope you have a wonderful rest of your week.